Hi everyone and welcome back. In this video, we're going to talk about the system design of YouTube streaming or any other type of video streaming. We're going to talk about the main processing components, things like encoders, decoders, transcoders, and distribution components, things like video segmentation, dynamic video construction, caching, and delivery. With that, let's get to the video. First, let's look high level on two main workflows, uploading a video or publishing it, and watching a video or streaming the video from the server to the end user. And as you can see on this diagram, high level view, as we upload the video, it goes to our application servers. Then we need to encode the video just so we can provide different formats of the video to the end user. And then we would just store all those different encodings of the video, let's say, into our blob storage. And then we would push it to CDN or content delivery network, just so that video or those video formats sit closer to the end user. For instance, if I upload a video in the United States and someone is watching it out in Australia, then my video would be stored in the blob storage in the US, for instance. And then if it's a popular video, it would be distributed across the CDN, and copies of the specific format of my video would end up in the server somewhere in Australia and would be streamed directly from the Australian server instead of the US server. So this is what CDN is, ability to distribute the static content around the world. And this is the other view of the streaming video. As you can see, we have a blob storage sitting, let's say it can be United States, and then we would have some application servers that would pull that video from the storage based on the popularity, and then perhaps push it to the CDN into the specific locations where this video is popular. And then this video gets streamed to the end user from the locations that is close to one. So this is high level how the system and workflows would look like. Now let's talk about it in more details. Let's start with the publishing video workflow and think about the data model. Let's say we shot a video and now we want to upload it on YouTube. So all we have is just a video format that has a audio stream and video stream. As we upload it on YouTube, we would need to extract a lot of data out of there or produce a new data, right? Because the data model on the YouTube would look differently. We would not only have a video stream and audio stream, we would also have a subtitles, we would have thumbnails, we would need to generate a preview. Perhaps we would need to transform this video into multiple formats so it's easily viewable on the mobile phone, on the smart TV, and all these different devices. So from a single file of video, we would need to extract a lot of data and then pre-generate a lot of different video formats for better user experience. So let's try to walk through the process. As you can see on this diagram, for instance, this is how it would look. First, as we upload the video to YouTube, we're going to store it in the original storage or some temporary storage, which would be a huge, probably HDFS system where we would just dump the video for future processing. We want to split the actual transcoding or processing on the video from the original storage because we don't know what kind of video is getting uploaded. We want to verify the video. We want to make sure that it's not a duplicate of some other video. So there is a bunch of checks that we want to do before we start processing video, extracting the audio, video, etc. So that's why we have this temporal storage for the original video. And then from there, we would send probably some sort of message to the Kafka queue or a distributed queue that would trigger a future processing. And as we think about this original video upload, we probably want to have a separate design or separate pipeline for this specific action because it's not restricted in any way. Anyone can upload a video on YouTube and millions of people can start doing it at the same time. So there are not really a lot of restrictions. At the same time, the video upload would probably eat a lot of bandwidth. So we would want that video upload pipeline be designed separately to make sure that we have incredibly large network, perhaps spread out across data center. At the same time, we have a lot of storage in the data center. So when I think about it, likely it would have a dedicated data centers that would only handle the video upload and would be equipped and designed specifically for high network throughput and high storage capacity. And then from that upload video data center, that video would be processed perhaps either locally or elsewhere, but we need that single huge pipeline for video upload, and we would probably want to have it in the United States, in the Europe, Asia, Australia, separate video upload pipelines, so we don't have to transfer terabytes of videos around the world, and we can use local pipelines for the video upload. As the video is uploaded to the original storage, we want to send a message to some distributed queue and let know the workers that the video is ready for processing. Since we'll be receiving hundreds or thousands of videos per second, then we would just notify the other systems about the video being stored and ready to be processed. And then the processing servers would take care of the video splitting, transcoding to different bitrates, storing it, and probably distribute it to the CDN. Every single stage in video processing would has to go through the messaging queue to make sure that every single step is decoupled from each other and can be scaled separately, and there are no bottlenecks in the process. Now, as you can see on this diagram, as the video gets transcoded to different formats and bitrates, we first want to store those different formats in our transcoded storage, which would likely be a HDFS system or some blob database. And once the transcoding is done, we would let the metadata servers know that so they can update the metadata DB and then also update the cache. It's important to know that as we talk about the video processing, it's not only going to be a single video transcoder that would take a video and create multiple formats. We would have a lot of different steps, and every single step would be separated by a queue, which means that every single step would be decoupled from other steps and would have a dedicated worker pool to perform a single action. For instance, as you can see over here, we would have a video splitter that would be only responsible for splitting videos into different segments and uploading them to either blob storage or HDFS. Then the next worker pool would take all those videos and, let's say, filter them on the piracy or duplicates or something else, and then store them back. And then we would have more filters like that, more processing worker pools that would perform a specific action. And once the action is done, the completion message would be sent to the queue so that the next thread pool can pick up the message and keep processing. And in the end, we would have a lot of already prepared videos, split it and convert it to different formats, ready to be streamed to the end user. Now let's briefly talk about how they would distribute those videos. So we mentioned CDN multiple times, but what is that and how can we get those videos close to the customer? So there are a lot of different ways to do it. Netflix does it its own way, but bottom line is the following. We have the origin servers, which is a blob database probably or a cache that has our different video formats. And then we want to identify which content is the most popular based on our prediction, and then push it closer to the user. When we say closer to the user, usually it means multiple things. First, it can be pushed to the IXP. IXP is a internet exchange point where a lot of service providers that provide internet service interconnect. So if the copy of the data is pushed to the IXP, then the internet service providers that locate it in the IXP can just read data from there, which is local to them, and then stream it to the end users. And there are a lot of different IXP points around the world, so you would just want to push your content, I would say, in all the IXPs around the world, and then all the local providers would serve that video from there. At the same time, if the content is very popular, internet service providers can also have a copy of that content locally in their own data centers and serve it from their own cache to get it even closer to the customers. Because there are only 630 IXPs around the world, but obviously there are thousands and thousands of data centers around the world, some of them owned by the internet providers, some of them owned by someone else. So step number one, we would want to push the content to the IXPs. So it's closer to all the internet service providers and everyone who is responsible for streaming this video. And if you want to get it even closer to the customer, then we can work with specific internet service providers to make sure that a copy of that content is located in the ISP, and service providers can just serve the content directly from the cache from the specific data center. So now, as we have, let's say, our content is published and distributed in the different ISPs and CDN, first, as the user requests a video, there is a API request for the video that comes to our system. We check whether this content is located close to the user or what the location of this content, and then we return to the user the closest location of the content that we have. If it's a CDN, then it's going to be a CDN location. If it's not in CDN, then we would just return the location of the video in our own blob storage. So we simply return a link back to the user, and that link points to the closest location of the content that the user is playing. And it can either be on the external CDN, or it can be in the ISP cache, or it can be literally in our own blob storage because the video is not popular and we decided not to push it anywhere and keep it locally. Now, when the user wants to watch a content, why do we want to return a link to the content? Why not just return the content itself? And the reason is not only because the content can be located in different locations. It can also be because we want to know what kind of device the user has, whether it's a phone or a TV or a laptop. And then based on the device that user has and the internet speed, we return the most appropriate and high quality video that the user's internet and device can support. And in this diagram, you can see how many different versions of the video we can store in our blob storage. We can have different video formats. We can have different audio formats, different subtitle tracks based on the language. And then in the same time, for every single video format, we can have different bit rates for the video based on the internet speed. So now, as we've seen how many different video and audio formats are there, let's talk a little bit about the transcoding and adaptive bitrate streaming. First, let's go through the main components of the video streaming. We have encoder and decoder, and the main purpose of this is to compress the video so it takes less space and can be faster transferred over the wire. So before transferring the video segment to the user, we want to encode it on the server and then decode it on the user side. Then we have a transcoding, and transcoding means that we're going to take a single video and then make different video formats with different bitrate, which means we'll have the same video of different qualities and different sizes. Just so if you watched on the small screen, we don't have to send a 4K quality video. The next component is video segmentation. Now, as we have it transcoded, we want to make sure that we split it into the set of segments that we send to the user gradually. So when I'm open a video, I don't need the whole video being downloaded at the same time. I want to just give the first segment. And then if my, for instance, internet speed fluctuates, then I can adjust to download either the lower quality segments or higher quality segments. For instance, on this diagram, you can see that the first segment, we got a really good quality segment, and then my internet speed perhaps got worsened. So I got really worst quality segment 2, and then better quality segment 3, and then got back to original quality on the segment 4 and 5. Because if my internet speed fluctuates, what we want to optimize for is no buffering. We don't want to have buffering, so it's better to send a lower quality segment of the video, just so the video keep playing back, than keep using the high quality segment video and then keep buffering them on the client side and ruin the user experience. So this is what adaptive bitrate means, that we have a video split into multiple segments, and then we download the segments of the quality that our internet speed allows us to do. So now when I open up a video, I receive a manifest file that has the segments of the video, different formats of those segments, and the location of them. So now the client, the playback client or the player that I'm using, can use this manifest file to download the segments that are appropriate for my internet speed and my device. As you can see on this diagram, segments are downloaded as they are needed based on the quality that my internet speed and device allows me to do. And there are multiple benefits of doing so. Obviously, the first one is that we can adjust the quality of the video and avoid buffering. But there is also an opportunity, for instance, to put some ads into it and construct that video dynamically based on my preference. For instance, when I open a YouTube video, I receive a manifest file with all the segments of that video and the ads that would be generated probably in the real time based on my interests. Or perhaps if you're having some educational website, you can insert multiple quizzes in the middle of the video, or you can add a different paywalls. For instance, you watched half of the video, and to watch the other half, you got to perform a specific action. So this adds a lot of flexibility and support for different business models, ability to generate your video out of the segments dynamically in the real time. Now let's wrap the video by talking about the codecs, container formats, and protocols. So first you want to look at the video streaming protocol and then see what it supports, what kind of video and audio codecs, what kind of transfer format, playback devices, segment duration, and based on that, we can plan what kind of system we want to build. But usually, like YouTube and Netflix, they support a lot of different protocols and different devices and different formats and a mix of them, which means that they have a lot of pre-generated formats for every single video. Netflix says that for every single video published, they generate up to 2,000 different video and audio formats to be able to serve users more efficiently and provide better user experience. All right, and this is it for this video. We've covered the high-level design for publishing and streaming, different components of streaming like transcoding, decoders, bitrate. We didn't talk about the database design, the API, the way they can improve the publishing on the video as it goes through multiple stages of tasks. If you want to learn more about this, check out my system design course. And if you like this video, make sure you like and subscribe, and I'll see you in the next one. Bye.